Good day, everyone. So, in today's lesson, we shall be looking at speed, velocity, and acceleration. At the end of this lesson, we'll be able to know the definition of this concept in motion and the graphical analysis of this concept, as well as the calculations involved. All right, so let's dive into this. I want to begin with speed. What is speed? That's one of the concepts of motion. So we say that speed actually measures how fast an object moves, whether the object is moving very fast or very slow. The term we use for such phenomenon is called speed. So, by the weak definition, we say it is the time rate of distance covered. Okay, the time it takes for an object to cover a particular distance is called speed. As you can see this car now, if you are interested in the time it takes for this car to cover a particular distance, then you are determining the speed. And it is a scalar quantity, meaning that has only magnitude, no direction. Because we talked about this in the last lesson. So by formula also, speed is distance divided by time based on the definition. So we say it is distance covered at a particular time interval or the time rate of distance covered. So by formula it is distance over time. By symbol you can say speed. We use V to represent speed by symbol. Sometimes we also use it to represent velocity. So the symbol V can be either speed or velocity. Some textbook use letter S to represent speed, but the universally accepted one is V. And lastly, the unit for speed is meter per second. Either you write it in full or in symbolic form, m/s. In fact, some other way to write this, the unit for speed can also express it in mathematical form. Maybe in this, it can be in this form as well. When you write speed, unit, say meter x is to power -1. Okay, instead of writing this way, you can also go this way. All right. So those are the three concepts or three important things about speed you must know: the definition, the formula, and then the unit. So we can now go to velocity, another thing in motion. Velocity is a little different from speed, but just slight different. Number one difference is that it is a vector quantity, while speed is a scalar quantity. So by definition, we can say that velocity is the time rate of displacement, while that of speed is time rate of distance, but velocity is time rate of change of displacement. So the difference here is that number one is a vector quantity, number two by definition is the time rate of change of displacement. So by formula, we say it is displacement over time. Okay, displacement, change in displacement over time. This triangle you see here means change. Okay, the Greek name is called delta. So delta x, where the s represents displacement. Okay, so delta x over delta t, change in displacement by change in time. So change in displacement by change in time gives off velocity. But when it is change in distance over change in time, that is giving us speed. All right. So the unit for speed is the same thing with that of velocity, meter per second. Okay. So they have the same speed, unit. That's the relation. That's what is common between them. They both have the same unit. So if you have to state the similarity between this velocity and speed, what you need to say is that they have the same unit, which is meter per second. And the differences between them is that speed is a scalar quantity, while velocity is a vector quantity. And last difference, you can state also the definition. Speed is the time rate of change of distance, while velocity is the time rate of change of displacement. All right. So we now go on to another aspect of the speed and velocity. Having known the definition, their formulas, and the unit, there's what we now call uniform speed or uniform velocity, and also non-uniform speed and non-uniform velocity. Either way, what matters there is the words to be used. When you talk about uniform speed, we say that an object has uniform speed when it covers equal distance in equal time intervals. So when an object covers equal distance in equal time interval, we say that that object is moving with what? Uniform speed. And another word for uniform speed is called constant speed. It's the same thing applies for velocity. If an object is moving with a uniform velocity, we say that the object covers equal displacement in equal time interval. So if it is velocity, we don't say distance, we say equal displacement in equal time interval. That is what uniform velocity. For uniform speed is equal distance covered in equal interval of time or time interval. Okay, so we say that another word for uniform speed or uniform, another word for uniform means constant. It means that the speed or the velocity is not changing. So we can say it is either uniform speed or constant speed. You can also say uniform velocity or constant velocity. An example is a train that travels 500 meters in 10 seconds. It's the same thing with the train when it travels with 50 when it travels 50 meters in 1 second. Because if you reduce it to the simplest ratio, it will be giving you 50 over 1. So that vehicle is moving with what? With a constant speed. It's not changing. On the other hand, when we say non-uniform speed, this object is covering on equal distance in equal interval of time. This time around, the distance covered is not the distance covered at a particular time is not the same always. For example, now an object covered 20 meters in 2 seconds. Then it covered 15 meters in 3 seconds. And then 25 meters in 5 seconds. This is an example of non-uniform speed. But if it is uniform speed, if you cover 20 meters in 2 seconds, then of course in 4 seconds it should be what? It should be covering 40 meters. Then in 3 seconds it should be what? It should be covering 30 meters. Okay, but in this case now, in 3 seconds it's covering 15 meters. In the first case, it covered 20 meters in 2 seconds, and then in the second scenario, it covered 15 meters in 3 seconds. So this is not uniform. If it's uniform, at the time it's increasing, it will be going uniformly with what? As the distance is being covered, the time also will be increasing gradually like that. But in this case now, at this point, the distance is 20 meters in 2 seconds. Now, when the distance reduces to 15 meters, the time increases to 3 seconds. So this is unequal or non-uniform speed or velocity. So when you are defining them, just know that if it is velocity you are defining, you will say that it is what? Unequal displacement cover an equal interval of time. That is for what? Non-uniform velocity. With non-uniform speed will be unequal distance cover an equal interval of time or time interval. So these definitions are very, very key that we know. Then we talk about displacement time graph or distance time graph. Whenever you see distance and time, you know you're talking about speed. If you see displacement and time, you know you're talking about what? Velocity. Now, this graph will either show us the graph of velocity or the graph of speed. All right. So if it is distance time graph, you know that you're talking about speed. So in distance time graph, on the vertical axis of the graph, it is distance that you will have. This S can mean two things. It can mean distance. It can also mean displacement, depending on what you are using it to represent. In this case now, because I want you to represent speed, So you're going to be representing distance. So for speed graph, you'll be having what the graph for speed is called distance time graph. And on the vertical part of it, it is the distance that you have there, while the horizontal you have time. Now the slope that you have, in distance time graph is referred to as the speed. And how do you get slope? It's just the maximum of the vertical line minus the minimum of the vertical line, okay? Then all over the maximum of the horizontal line minus the minimum of the horizontal line. So what do I mean? Maybe I should portray that more. Now look at this. Look at this graph again. You could see here, this is the maximum part. Trace it down to the vertical part. Okay, that's it. Let's call this one S2. That is second distance. Now the minimum part is this. So this is S1. Okay, that for the distance. Okay, distance 2, distance 1. And the horizontal part, this is timeline now. Let's call this one T2. And this other part, I'll call it T1. Now if you want to find the slope now, slopes formula says change in distance, that's the vertical part, over change in time. Change in time. All right. So we have time here, change in time. And that will be equal to change in distance will be S2 minus S1 over T2 minus T1. All right, that's it. So this S2 minus S1 over T2 minus T1 means change in distance over change in time. And that is the formula for what? For speed. Remember that speed is change in distance over change in time. So the slope of distance time graph give us speed. See on the same scenario, if we now take this vertical line to be displacement instead of distance, it will now be change in displacement over time. So the graph of velocity is called displacement time graph, and the slope you obtain under that graph is called the velocity. Okay, it's called velocity. Very, very important that you know. All right. So if the distance time graph, it is for what? Speed. If it is displacement time graph, it is for velocity. All right. So let's move on to the third term in motion, that is called acceleration. Acceleration is the time rate of change of velocity with time. Okay, you don't need to say with time anymore. So when you say the time rate of change of velocity, that's okay. But if you want to involve time at the end, you can say it's the rate of change of velocity with time. So by formula, velocity is what? Change of velocity over change in time. Okay, let us make that bold. So change in velocity over change in time. So by formula, we can say that acceleration, we use symbol theta A to represent acceleration of what? Change in velocity. We use V to represent velocity over change in time. So this is the formula for acceleration. All right. So for example, now a car that starts moving from rest, as in from zero level, and then gradually increases velocity from 0 to 20 meters per second within a time interval of 10 seconds, then the velocity will be what? 20. By formula, let me make the formula for acceleration more clear. Acceleration is change in velocity, which is v2 and v1, over change in time with t2 and t1. So in this case now, using this one as an example, our v2 will be 20, our v1 is 0. Okay, so that will be 20 minus 0 over the time interval is 10. So 20 over 10, that will give us 2. So 2 meters per second square. So the acceleration here, that's how we got this. Now there are cases where the vehicle will gradually be slowing down. In that case now, it's decelerating. We call it deceleration. Instead of the car to be increasing from 0 to 20 meters per second of speed, it will be reducing. Maybe it wants to stop, maybe it wants to gradually park. So in that case, we say the car is decelerating. In that case now, our V1 will now be the bigger one because that's the initial velocity before it gradually slow down to 0. While our V2 will now be the 0. Okay. So if you want to get the deceleration, you always get a negative answer because in that case now you'll be having 0 minus 15 because it will be V2 minus V1, that will be 0 minus 15 over the time interval, which is 5 in this case. That is how we have it to be minus 3 meters per second square. So deceleration always have a negative symbol to indicate that the object is reducing in speed. All right, so that's it. Now let's also consider what we call velocity time graph. We've looked at distance time graph, which is for speed. We also look at displacement time graph, which is for velocity. Now we now have velocity time graph. What do you think this one will be for? It will be for acceleration. So in velocity time graph, what you have here, you also in a graph you always have vertical axis and horizontal axis. So on the vertical axis for velocity time graph, what you have there is velocity. Okay, so over here you have velocity. You have velocity on the vertical axis. All right. So in this aspect here, velocity is here. This vertical part is velocity. So we have velocity here, then the unit slash the unit, which is meter per second. Okay, meter per second. While on the horizontal axis, of course, is time. This slash the unit, which is second. So that's it. Now this velocity time graph is a little different from that of displacement time graph or distance time graph. Okay. Now the similarity here actually is the axis. Okay, the vertical and horizontal axis, they have it, and then you can also get slope. But in this case, you can see that the curve here is kind of complex. So sometimes the journey can be this complex. But let me explain what the journey means. When the object, this line here, this line you're seeing, that goes like this, that's the journey that the object is moving. It goes like this, then it goes this way, and then it goes down. Okay, all these have terminologies, and let's break it down. Okay, let's break those terminologies down. Now I'm starting with 0 to A, between this point and this point. We call it acceleration because the object is what? Gradually increasing its velocity. So the velocity starts from 0 and gradually increase to 30. Okay, this is the level at which the velocity of the vehicle reach. Okay, at 30 meters per second. So whenever velocity is increasing, we see it is accelerating. So the vehicle accelerated from 0 to 30 meters per second. So from 0 to A is called acceleration because the velocity increased from 0 to 30. But when it got to point A, it never accelerates again. It now maintain that 30 from A to B. So whenever an object is not accelerating, we say it is moving with a constant velocity because the velocity is now 30, it's not increasing again. So between A and B, it is what? Constant velocity. Now at this point again, the velocity begins to increase from 30 down, it reduces down to 0 again. Whenever velocity is reducing, it is called deceleration, or another word is retardation. So at this point, that's retarded. And is it okay? So that's it here. Now at every stage, it takes time to to cover such distance. When it was accelerating from 0 to 30 meters per second, it took that object 5 seconds for because this is timeline, the horizontal is timeline. So it took the vehicle or the object 5 seconds to accelerate from 0 to 30, like between 0 to 5 to get to this 30. Now between point A to B, when it's not accelerating, it's maintaining that 30. It took it another 15 seconds. 5 to 20 is 15 seconds. So at constant velocity, the vehicle took 15 seconds. Now from B down to C, it was decelerating. That means acceleration was velocity was reducing. In that case, it took the object 10 seconds, 20 to 30 is 10 seconds to decelerate or to retard. So this is the explanation behind the graph. Okay, all of these thing you could see here is called the curve of the graph. Now the shape you can see now, this shape, you observe where we could see the first stage we have triangle shape, second stage we have rectangle, third stage you have triangle. So you can find the area of each of them and add them up. When you add them up together, the result is always called the total distance covered by the vehicle. All right. And if you don't want to do that, you can look at the shape in general. It's looking like a trapezium shape. So instead of going this way, like the area of a triangle plus the area of a rectangle plus the area of a triangle here, you can just use the area of a trapezium. We still get the same result in getting the total distance covered. All right. So that's the explanation behind this velocity time graph. And in our next class, we'll be looking at the calculations involved in velocity time graph. Okay. We also look at calculation involved in displacement time graph and distance time graph, as well as velocity itself and speed itself. So what the calculation that is involved, we are going to consider them so we can know how it's being applied. Okay, but for today, let's just look at the last concept, which is the motion under gravity. When we say motion under gravity, we say that they are motion that have been affected by what? By gravity. And we normally make use of these four formulas. We call them equation of motion to determine such motion. Okay, so we use the first one, which is we can use any of them depending on the scenario. Okay, it will also be part of our next lesson to see how to apply this formula. First one is v equal to u plus at. Second one is v squared equal to u squared plus 2as. Third one is s equal to ut plus half at squared. And the last one is s equal to open bracket v plus u close bracket t divided by 2. So I hope you have learned something today about the concepts in motion, such as speed, velocity, acceleration, and motion under gravity. Thank you for listening. In our next class, we will continue. Bye for now.